Hey everyone, hope you are doing well. Today I'm going to teach you how to integrate, and I'm calling this basic integration because it's how you integrate like 3x plus 2 or 5x squared plus 7x plus 3, because I'm not going to teach you how to integrate like e to the power of x or sine of x or anything like that. I'm just going to teach you how to integrate, standard basic integration questions. So obviously as part of that, I'll teach you how to do these two questions and all the steps you need to do. So jumping into question one, this is the integration symbol. So it's kind of like an elongated S. So you're integrating and you're integrating everything within this bracket. There might not always be a bracket, but I think it's a bit cleaner. So you're integrating all of this. And in this case, it's with respect to x. So we have x in this, I guess you can call it, in a formula or whatever you want to call it. We're integrating this. So we're 3x plus 2 and we're integrating with respect to x, okay? So when you integrate, you add 1 to the power and then you divide by the new power. So in this case, we would have, I'll come this side, 3x squared. So we're adding 1 to the power because this would have been 1, or to the power of 1, which is 3x. Then you divide it by the new power. So for this part, it's going to be 3x squared over 2, or 3 over 2 times x squared. Now, when you have a constant when you integrate, you just times it by x, and I'll explain why. So 2 is effectively the same as 2 times 1, which is the same as 2 times x to the power of 0, because anything to the power of 0 is 1. So it's effectively 2x to the power of 0. If you added 1 to that power, it'd be 2x, divided by the new power is 1, which is 2x. So anything divided by 1 is itself still. So that's why you times a constant by x. So that's the logic. You don't need to remember that. But if you have a constant, remember to times it by an x, or I guess whatever you're integrating with. So you could integrate with respect to y or z, whatever it's asking you to integrate with respect to. And last but not least, you have to remember to put a plus c. So c is an unknown constant. A constant is exactly like it sounds. It could be a 7, it could be a 2.3. It's a constant number that doesn't change, and it could be 0 even, but you put that constant in because if we were to differentiate this, we would get rid of any constant. It would just be gone, and the 2x would go to 2, and this would be times that by, you times the 2 by here, so you have 6 divided, you'd have 6x, 1 off the power divided by 2, so you'd have 3x to the power of 1, or 3x. So you need to kind of take that into account when you're integrating, because I guess in a sense integration is the opposite of differentiation. And there will be questions where you might have to work that out. Let's say, for example, y is equal to the integration of this, or y is equal to this, and we get given 2 points, so we get given an x and a y. We could substitute those in to find out c. There will just be questions where you don't have to do it though. You just have to remember to put the plus c, and you're not always going to be, asked to, work out what c is. So you don't need to worry about it too much. You just need to remember to add it every time you integrate. So I don't know if you want to give question number 2 a go. All you have to do is make sure that you add 1 to the power and then divide by the new power. And hopefully you remember what I said with the constants. Well, 3 is the constant here, and then you add c as a unknown constant. So tackling this question, starting with the 5x squared, you add 1 to the power, so that becomes 5x cubed. You divide it by the new power, so it's 5x cubed over 3 plus 7x squared over 2 plus 3x, because remember, we're integrating with respect to x, so we just times it by x, and then we add a plus c, because we have an unknown constant. So hopefully that makes sense. Hopefully it was clear. If you do have any comments or questions, let me know. But hopefully that was just a basic introduction to integration. And if you made it this far, I appreciate you watching the video, and best luck with your maths.